So this video is for specific heat capacity, and we're going to use page 379 examples and walk through those to help us understand what to do. Okay, so first we need to add a few words to our symbol chart. Okay, so this, we have Q, which is good. Okay, that's energy. And then we have M, which is good. We have mass. Okay, and then the new ones are C, okay, which means specific heat capacity of a substance. So certain things heat up really fast and certain things heat up really slow. Oh, I'll put that on mute so everybody doesn't have to listen to the video recording. Okay, so heat up really slow. So that's measured in joules per gram per degrees Celsius. Okay, so joules, notice how it's different from kilojoules. Joules per gram times degrees Celsius. Okay, so that means we're going to have energy in there and mass and temperature. Okay, so what's this called? This is called specific heat capacity. Okay, capacity. So things that are really good at conducting heat are going to heat up fast and cool down fast, and things that are better insulators like air is going to heat up slower. Okay, so in your book it has this calorimeter thing, okay, showing you how you test it. Okay, so if you're using water or some other material, okay, you're testing how much it heats up and cools down, and you time it, and you put it in a container that's insulated so it doesn't, it's not affected by other factors in the atmosphere. Okay, so we need to add a new formula, and we need to add the change in temperature. So this little delta, this means delta, it's a little triangle. Okay, delta T. I do my T's like this in science to make it look different than a plus. Okay, because sometimes it gets mixed up with a plus. So it matters that this is a lowercase c, lowercase n, lowercase m, because look, this is two different things, whether it's uppercase or lowercase. Okay, so get in the habit of writing it perfectly and not being sloppy with your writing. Okay, so what's this? This is change in temperature. Okay, so we're going to math it up and do some subtraction. Okay, so you've added this to your notes, and that's going to be degrees Celsius. Okay, we're not dealing in Fahrenheit here because we live in Canada. Okay, then we have a new formula that we need. Okay, Q, energy, is mass times specific heat capacity times temperature change. Okay, so if anybody asked you what's mass, okay, that's going to be Q over C times temperature change. If they're asking you for specific heat capacity, that's going to be energy divided by mass times change in temperature. And if they're asking you for temperature, that's going to be energy divided by mass times specific heat capacity. Okay, so those are formulas we might need for some reason. Okay, and then change of temperature is just the big one minus the little one. Okay, so we'll do like a little side note here. So change in temperature is the hotter one minus the colder one, like, I don't know, 20 degrees minus 10 degrees. The change in temperature there would be 10 degrees. Okay, and always put Celsius. Right, so now let's do an actual practice question. Okay, so this is from the book, and we're just going to walk through it together. Which one should we do first? Let's do the top one. Sure, why not? Okay, so we're looking at page 379 here, and we're looking at D2.1. So pause the video and open the book. Okay, what you should do is try to do this question without me first. Okay, you're always trying to figure out lessons by yourself, and then if you can't do it, you ask your teacher, okay, or you watch the video where your teacher explains it, okay, which in this case is me. So first thing you do is you fish out your variables. Okay, let's write the steps a little bit here, just to remind us. Okay, list your variables. What's a variable? The numbers. Okay, so we have a 50-gram mass. Okay, what symbol is grams? Okay, mass, which is a little m, of water at 25 degrees Celsius. So let's put temperature 1 is 25 degrees Celsius. And we're always putting the decimals. We don't just put 25 because we feel like it. Okay, and then temperature 2 is 50 degrees Celsius on a hot plate, okay, given the specific heat capacity of water. And you might as well memorize this number because we do water a lot. Okay, 4.19 joules per gram times degrees Celsius. And we need to find Q. Okay, it's saying, what is Q? So let's put a question mark, and let's put what's going to be measured in. Okay, it's going to be energy. So should end up with joules. Okay, except if it's a big number, quite often what we'll do is we'll turn it into kilojoules. Okay, so there, we listed our variables. Step 2, plug the numbers, or formula. Okay, so we're going to do Q equals MC delta T. Now, we don't have delta T. We need to figure it out. So, I don't really care where you put it. I'm going to put it here. Okay, so change in temperature is the hot one minus the cold one. Okay, in this case, this is the hot one, that's the cold one. Because we don't want negative numbers, right? So 50 minus 25. Okay, my brain calculator says it's 25. And we're keeping the decimal. Okay, so now I have that for a variable that I can use. Now I'm going to plug the numbers in. Q, still don't know what that is. See how I'm not putting equals, I'm putting Q equals so I don't forget what I'm calculating here. Now the M is mass. And I find science people like to put things in brackets just to keep everything together. Okay, so let's do that because we're science people. Okay, and then times, when they're stuck together like that, that means times, you multiply. Okay, 4.19 joules per gram per degree Celsius. See how we're not being lazy? We're putting all our units all the time. And then the next one is delta T. We figured that out, was 25 degrees Celsius. Okay, and then we ask the calculator, or just look in the book because it's available, what the answer is. Okay, so 50 times 4.19 times 25. You know, let's put the unrounded answer here, like where you don't round it first. So 237.5 joules. Okay, which is kind of fine, right? We have the right amount of significant digits. There's one number after the decimal, one number, one number, one number, two numbers. So you always go with the smallest amount of significant digits. So this is only 1, so we can only have one decimal in our answer. Okay, so you can leave it like that, technically. Nothing wrong with that. But a lot of people like putting their energy in kilojoules. Okay, so how many joules in a kilojoule? 1,000 joules in a kilojoule. So divide by 1,000. So move the decimal over 3 times. Okay, so you end up with 5.2375 kilojoules, but we don't like all these extra significant digits. So let's round to 5.2 kilojoules. I find that interesting that in your textbook they put 5.24 when they shouldn't. Okay, you should only have it rounded to the 1 decimal here, because that's the significant digits. Okay, or some people call them sig digs. Okay, so significant digits. So that's how you do that one. And what's different about the next question? Sometimes they try to be sneaky. Okay, so if you're looking at page 379, the next question, D2.2. Okay, it's the same process as up here. Okay, but what's different in the question is they give you mass in kilograms. Okay, and we don't want mass in kilograms. Okay, when we're using this formula, Q equals MC delta T, this needs to be in grams. Okay, so you need to convert that first. So same as 1,000 joules is a kilojoule, 1,000 grams is a kilogram. Okay, so 1 kilogram is 1,000 grams. Okay, let's do a practice. Let's do some math. Ready? So if I put, let's do a different color. Okay, let's put 1, 2, 3, 4. Yeah, let's put that like that. Okay, kilograms. And let's put the decimal here. And let's put the decimal here. Okay, and let's do some grams ones. Okay, so now pause the video, try to put the answers your own self. Okay, and then look over here for how to convert them. Okay, so to go from grams to kilograms, you're going to multiply by 1,000. Okay, so that means it gets bigger, right? Move the decimal over 1, 2, 3, or punch it in your calculator. Okay, 123.4, move the decimal over 3 times. So your number is getting bigger. 1, 2, 3. Okay, now this one, move the decimal over 3 times because we're timesing it by 1,000. 1, 2, 3, so it should be 123.4 grams. Now we're going the other way. Okay, so to go from grams to kilograms, you're going divided by 1,000. So your number is going to get smaller. Okay, so we moved the decimal this way last time. Now we're going to move this way. Okay, so decimals here, 1, 2, 3. And this way, 1, 2, 3. So if you run out of numbers, you add some zeros. Okay, so add a 0 there, and the decimal has to be here, so add another 0. So our answer is 0.0123 kilograms. Okay, so that was what was different in the 2.2. And for 2.3 and 2.4, it's the same procedure where you list your variables, you put your formula, plug the numbers, and put the answers, except instead of calculating for Q this time, you'd be calculating for delta T and C. Okay, so you would go and use these formulas instead, which you wrote down right here. Okay, so for the example on page 380, it's asking for change in temperature. Okay, so you would use this formula. And in D2.4, they're asking you for what's the specific heat capacity, and you use this formula. Okay, so as long as you follow these steps and you have your formulas and your variables written down, you can do any calculation. Okay, if there's one you're having trouble with, let me know and I will document camera for you and help you do the question. Okay, and then I'll probably record it for everybody else.